Welcome to my channel. In today's discussion, we will learn sign convention for light reflection by spherical mirrors. Now, what is sign convention? Why do we need it? Cartesian sign convention is used to measure various distances in the ray diagrams. I have discussed thoroughly ray diagrams in my last two videos, so you can watch them. Then, why do we need to measure these distances? In order to solve problems based on light reflection using spherical mirrors, either concave or convex. Now, there are certain fundamental points that we need to understand, based on which we will learn how distances are measured. Now, for example, I consider a concave mirror which is curved inward and coated outside like this. Now, if I consider this, the center of this surface, mirror surface, as P, then with the P as origin, the distances are measured. So, the first point is all the distances are measured with pole P as origin. So, if I consider this line, so this line will become the y-axis and this is the principal axis. So, principal axis is the x-axis and line passing through pole perpendicular to it is considered as y-axis. So, this is our x-axis and this is our y-axis with point of intersection as origin denoted as pole. Now, the object is always placed, the second important point, the object, whether it is concave mirror or this is convex mirror. We have discussed in my last videos that object is always to the left of pole. So, the object is placed to the left of the pole or origin, and therefore, light from the object, suppose this is the object, light from the object falls on the mirror from the left side, either here or in, this is concave and this is convex. So, light, this is the incident light in both the cases when we look at. So, this is object AB. So, the light is coming from the object which is placed to the left of the mirror. Mirror means reflecting surface. So, here it is concave mirror, here it is convex mirror. So, always the object distance, therefore, is always negative, whether it is concave mirror or convex mirror. So, I will consider object distance as denoted as small u. So, object distance is negative. Then, all the distances parallel to the principal axis means this is the principal axis. So, this is parallel to the principal axis. From the pole as origin, which I already mentioned. Now, this is the height of the object. So, I will consider the height of the object, and suppose say the image is formed somewhere at focus, for example. So, how is the image formed? Between, or some case we have discussed, image is formed like this, diminished and all. So, or in the case of convex, you have either at F or between P and F erect image. Now, this image distance I will consider it as h dash. I will consider that as h dash. Now, all the distances measured perpendicular to the principal axis above, that means this is x axis and this is y axis. So, positive y axis and this is negative y axis, negative y axis. So, this is negative y, this is positive y. So, the third rule is all the distances measured perpendicular to the principal axis above, perpendicular to above principal axis are taken as positive. So, here object distance, therefore, here object distance or height, height of the object h is positive, either in this case or in this case, concave or convex, object height is positive. Now, image, height of the image, that is perpendicular to below the principal axis, below the principal axis. So, this is below the principal axis and that is considered as negative. And in the convex case, the same h dash is perpendicular above the principal axis here. So, it is positive, it is positive, it is negative, it is positive. So, what is the rule? All the distances measured perpendicular to principal axis above are taken as positive, below are taken as negative. That means going along y direction, above means along y direction are taken as positive, below y direction or below the principal axis in the negative y direction are taken as negative. Now, the light is incident from left to right, and if the distance is measured from in the same direction as that of the incident light, same direction as that of the incident light, it is considered to be as positive distance. Even otherwise, we can see that the distance is measured from pole towards right. So, towards the right it is positive, origin we know, origin towards right positive, origin towards left negative. So, in the direction is what? Left, this is left to right, left to right, this is incident, and if the measurement is in the direction of the incident light, that is positive distance. Suppose it is taken in the negative direction. Suppose we will consider in the negative direction. If the distances are measured from the pole towards negative direction, that is from right to left, right to left away from the pole. in this direction, which means what? This is against or opposite to the incident light, opposite to incident light. So, if that is the case, then it is considered as negative distance measurement. It is negative. For example, what is focal length in the case of concave mirror? From pole to, let us say this is F, focus. Then this distance is focal length F, but it is to the left, it is to the left, therefore F is negative for a concave mirror. Whereas the same for a convex mirror, from pole to focus is F, which is measured to the right from the pole. So, it is positive. Therefore, F is equal to positive. So, having understood these points, we will now tabulate all these conditions and see how you can use this table for solving problems. Now, let us look at this. First point, object distance. Now, I am giving you as a consolidated table with these points so that you can easily take this table, understand and use it in solving problems in spherical mirrors. Object, the first one is object distance, and what is the letter that we are denoting? U. And what is object distance? Object is always used to the left of the mirror. Therefore, from pole it is to the left. Therefore, object distance U is always negative, which we have already discussed. So, object distance is negative in both the cases, concave as well as convex. Then image distance is denoted with a letter V, small v. Now, we have seen that in my previous videos, please watch them if you have not watched them. Concave mirror gives either real and inverted, or in only one case it gives a virtual and erect image. So, real means real and inverted means it is below the, like this, it is below the principal axis down. So, the distance is negative. And image height or image distance. Then in the case of convex, it is always virtual and erect. Therefore, image distance is positive. What do I mean by that? See, virtual image is always here behind the mirror. So, virtual image is always behind the mirror, and if I consider this as V, image distance from the pole, this is to the right, therefore it is positive. And if I consider the image distance here, this is the image distance V, and here it is to the left, therefore it is negative. So, in the case of concave mirror, you can have real or you can have virtual, and if it is real, it is negative. If it is virtual, image distance is positive. In the case of convex mirror, it is always either at F or between pole and F, that is behind the mirror. So, it is always positive. So, negative in case it is a real image, positive in case it is a virtual image. Because in concave mirror, you can either have, most of the cases you will have real image, and only in one case when the object is between pole and focus, you will have the virtual image. So, this is virtual. Then convex, you have only one case, virtual image and erect, therefore you will always have positive. Then focal length, I already discussed. In the case of concave mirror, focal length is from pole to F, and it is to the left of it, therefore focal length is negative, and in the case of convex mirror, focal length is positive. So, focal length positive, focal length negative, I explained. So, f is negative for concave and positive for convex. Then height of the object, either case you look at either concave or convex, the object is always above the principal axis, therefore h is always positive, h is always positive. So, object height of the object is always positive in both the cases. Then height of the image, as I have discussed, in the case of concave mirror, the image may be real and inverted. So, if it is inverted, it is below the principal axis, therefore it is negative, and if it is virtual and erect, then it is above the principal axis, therefore it will be positive. So, what do I mean by that? Suppose this is real and inverted image. Inverted image is below the principal axis in the negative y direction, therefore the height of the image will be h dash will be negative. If the image is behind the mirror, this is virtual and then this is erect, then this will be above the principal axis, therefore it will be h dash will be positive here. And in the case of convex mirror, the image is always above the principal axis because it is behind the mirror and therefore it is positive. So, we have seen that erect, it is virtual and erect, therefore it is positive in the case of convex. And then magnification, this I am going to discuss in my next video, magnification, and that will be negative or positive because you have real or virtual image or inverted or erect image in the case of concave, and it is always positive in the case of convex because you only have virtual and erect in the case of convex. So, this is the table which will help you to understand how these are negative and easy to remember, negative, positive and all these conditions, and easy to remember, and this is useful in solving problems. Next video I will discuss magnification and mirror formula for spherical mirrors. Until then, keep watching, keep learning. Thank you.